Okay, so we're into lesson 2, which, as promised, we'll be talking about vehicles. The next 3 lessons, I think it is, talk about buying cars and dealing with cars and the cost of having cars. But today's lesson is mostly on purchasing, so maybe there's finance involved, maybe there's a trade-in, but most importantly, this idea that cars will generally depreciate in value. Now, obviously, there's some cars that don't, but most cars lose a fair bit of their value, particularly in the first few years of ownership, and then a slightly less amount of value every year afterwards. But generally, cars are going to go down in value as they get older. Okay, so just going through this particular example we've got here, Lewis is interested in buying himself a Toyota Camry. A cost of a new one would be $36,000, but he can buy a second-hand one for $27,000. So how much is he saving? So his saving is just going to be... there we go. The saving is just going to be the $36,000 that he would have paid minus the $27,000 that he will pay if he buys the cheaper one. And you can use your calculator there, but the answer comes out to be $9,000. Okay, so what's the percentage on the price of the new car? So percent saving, obviously every time we make a percentage, we're making a fraction and timesing by 100. And in this particular fraction, the saving is what we're looking at. So that goes up top. And as a percentage of the price of the new car, so that was $36,000. But generally, we should get used to the idea that the initial condition is what goes at the bottom of that fraction. Now, once again, you can use your calculator, but I'm having a bit of computer trouble. So I'm just going to skip that and tell you that that's 25%. Okay. Moving on to the next example, a new Nissan Patrol costs $78,932, and you can save 25% by purchasing an old one. So calculate the amount of saving that can be made. So obviously the saving is just going to be 25% times by the cost of the new one, so $78,932. So we can use our calculator for that. So 25% times by 78932. And that gets us to 19,733. Okay, so to calculate the price on a 1-year patrol, that's going to be the new price better say what it is. New price minus the saving, which is going to be that 78,932. Take away the 19,733. So $59,199. Okay. Then we've got a 1-year-old motorbike, a Panigale. I don't know my motorbikes, to be honest. For a 1-year-old one costs $32,990. This has been decreased 12% on the price of the same bike when sold when new. Now, the important thing here is we don't actually know what the original price is. We just know that the discounted price is $32,990 and the decrease was 12%. So another way to think about this is that $32,990 is exactly equal to 88% of the original price. I'm going to use OP for original price there. Okay, and this is one of those situations where I would use the unitary method. So we sit there and go, well, okay, I know that $32,990 represents 88% of the original price, so I wonder if I divide this side by 88, I'll find out what 1% of the original price is. And of course, whatever I do to one side, just like in algebra, I've got to do to the other. So we can divide both sides by 88. When I do that, obviously on this side, I'm going to know what 1% of the original price is. But I'll need to use my calculator to find out what 32,990 divided by, divided by 88 is. And I get 374.886. I'm just going to leave some dots there to say, look, there's more stuff in my calculator, but I'm just not going to write it down now. So that's what 1% is. 1% is not that useful to us. Obviously, if I multiply 1% by 100, I'll find out what 100% of the original price was, which will be much more useful to me. But of course, same as before, whatever I do to one side, I've got to do to the other. And so 100% of the original price is going to be that number in my calculator times by 100. So $37,488.64. 37,488.64. So I can say original price equals $37,488. There we go. 0.64. Apologies for the bad writing. It's a bit hard to write facing up, and there's a bit of lag with my computer. It doesn't like using pen and recording at the same time, so a bit of a lag in there. Okay, now sometimes when we choose to sell sometimes when you buy a new car, you can choose to sell your old car to the dealer and they'll give you a trade-in. Usually trade-in's not as good as the amount of money you get for selling a car privately, but you don't have to actually bother with trying to sell your car privately. So depending on how much time you've got and how much you value that, you might think, look, I'll just take the trade-in from the dealer and I don't care if it's a little bit less than what I get for it elsewhere. At least it gets rid of the car. So all we're going to do is pay a little bit less for the car, because instead of paying, in this case, $38,000 for the car, we're going to pay $38,000 for the car, but $4,800 of that's going to be in terms of in the form of giving them our old car. So the amount of money we still have left to pay will be the difference between those. So price is going to be that $38,000 take away. I'll just make that 3 look a bit better. Take away the $4,800 that we got trade-in on our old car. So we can just pop that into our calculator. $33,200. Okay. And then, of course, a lot of the time people get finance to buy cars because it's a lot of money. Generally, most people don't have that sort of cash just lying around. Sometimes, however, before you get finance, you have to pay some sort of a deposit. So you pay a certain amount up front, and then the rest is covered by your repayments. So here we've got Eric borrowing $12,000 to buy a car at 8.5% interest, flat rate. So flat rate, whenever I see that, I'm just going to think, well, flat rate just means simple interest. And of course, we've done simple interest in the previous topic. Sorry about that small issue with my computer. It's really not liking what I'm doing with it today. Okay, so we've got to pay the loan over 3 years. So first thing we need to do is work out our interest. So we're going to use that I equals PRN simple interest formula. And in this case, the principal is $12,000. The rate, which we're going to express as a decimal, is 8.5%, so 0.085. And we're doing that for 3 years. Now, it's an annual interest rate and an amount of years, so everything works out nicely there. Okay, so we'll put that into our calculator, which 12,000 times by 0.085 times by 3. So $3,060 interest. Now, obviously, we don't just pay $3,060 back. We have to pay the total amount, which is going to be the principal initially plus the interest as well. So in this case, that's going to be $12,000 plus the $3,060. So you can use your calculator for that, but I'll just zoom that up there. The total amount is going to be $15,060. And there we go. Sorry if that was a bit skippy. I'm having real problems with my computer right now. Okay, we'll just have a look at what else we got to do. Okay, so Sky is borrowing borrows $15,000 to buy a car. This is going to be repaid over 5 years at $420 per month. So we're going to calculate the flat rate of interest that Sky has been charged. So for this particular one, we just need to work out how much her total repayments are first. I'm just going to pause 1 second. All right, hopefully that speeds up issues I'm having with my computer. We'll see how we go. We've got total payments is going to be $420 per month times by 5 years. So 5 lots of 12 months you could do. And so we'll work that out with our calculator there. So 420 times by 5 times by 12 gives us 25,200. Okay, so what we've actually got here is a situation where we know our principal, that's there. We know our interest, that's there. And we know our number of periods there. What we don't know is the rate. So we can substitute into I equals PRN. And in this case, actually that's not the interest, my mistake. So the interest is actually going to be 15,000. Oh, sorry, messed up again. 25,200 minus $15,000. Okay, which we should get as $10,200. You can use your calculator for that though. So in this case, that's our interest. So $10,200 is the interest paid. The principal is $15,000. The rate I don't know. And the number of periods though is 5 times 12 or 60. Sorry, 5 years. Not having a good day at all. In this particular case, we can use 5 years because we're after an annual interest rate. So the first thing I can do is work out what 15,000 times by 5 is. And I can say, well, I've got $10,200 equals 75,000 times by R. And so we're just doing a bit of basic algebra here. If we divide this side by 75,000, then those two are going to cancel out. But that means I've got to divide the other side by $75,000 as well. And that means that we'll end up with $0.136. Now, obviously that's a decimal. I can say over here, therefore the rate is 13.6% per annum. Okay. And I'll just see if I can get through this last question. The next question, we'll probably skip the very, very last one there because it's a bit of a doozy. Okay, so four-wheel drives for sale at $65,000, finances available at $7,000, and payments of $2,120 for 5 years. So for part A, the total cost of the payments is $2,120 times by 5 years, but of course it's monthly repayments, so times by 12 months. So we can put that into our calculator. 2,120 times by 5 times by 12 gives us $127,200. The total cost of using this package is going to be all of those payments plus the deposit. So that's going to be that $127,200 plus the deposit of $7,000. So that's going to be $134,200. And finally for C, the interest paid is going to be the difference between how much the car costs and how much we actually paid. Everything else must be interest. So it's going to be that $134,200 minus $65,000 that the car originally cost us. And so we can work that out on our calculator. 134,200 take away 65,000 gets me to 69,200. And that's the total interest paid. And I've pretty much run out of time. We'll skip example 8, just get stuck into the questions for today. Thanks.